Okay, let's do some of these uh, integration by partial fractions on this presentation worksheet. So, does this factor? Well, I think this factors to 2x uh, plus 1 and x minus 1 minus 2x plus, yes. And if you don't, you can also just graph this and it crosses at minus 1/2 and at plus 1. And so if it crosses at those two places, this parabola, minus 1/2, means the factor is x plus 1/2, or if you multiply by 2, 2x plus 1. And if it crosses at plus 1, x minus 1 has to be a factor. So you can factor by graphing. That's what all that was about. But anyway, so this fraction should be able to be written as, that's a linear factor, so you put a over it, and you put b over this one, because it's a linear factor. It doesn't have any squares in it. And this can turn into the integral of this plus the integral of this. If we can just figure out the a and b's that make these two fractions add to be that fraction. To add fractions, you need a common denominator, so you think this one needs to be multiplied by x minus 1, and this one, to get a common denominator, would have to be multiplied by 2x plus 1, numerator and denominator. But I'm not going to do that because I know what the answer is going to be there. I just have to figure out what a is, so that a times this plus b times this turns out to be 4. So what I'm trying to figure out is 4 is equal to a times x minus 1 plus b times 2x plus 1. Now, I've done this with matrices with you, and I'll just show this what this means. Over here, I have no x's, so I'm thinking about the x's. So no x's has to equal, over here I have ax's, and here I have plus 2b worth of x's. And then I'm going to look at the constant, and there's a 4. And here I have minus 1a, and here I have plus b. And I can type this as in matrices, but this is pretty simple. I can just add these two, the a's drop out, and I get 4 equals 3b. So b equals 4/3. And if b is 4/3 times 2, that's 8/3. So a would have to be minus 8/3 to get 0. So this integration is really, the a is minus 8/3, so I could write the minus 8/3 here and call that 1. And I could write the b out here as 4/3, call that 1. And then I can integrate this. If I let u be this, it turns out that dx would be du over 2, so this becomes minus 8/3 ln 2x plus 1 over 2, because of the 2 there, chain rule causes that to happen, plus 4/3 ln absolute value of x minus 1. Okay. This one. So you might not see how this factors, so you might go to your calculator and, like I said, graph it. So I have 2x to the third minus 3x squared plus 1. Graph looks like it goes from minus 1/2. So that means probably it's 2x plus 1 again, and it bounces at plus 1. So that means x minus 1 twice and 2x plus 1 might be the factors. Now, the quick way to check that is just to type that in, make sure I got it right. 2x plus 1. Oop. Insert a parenthesis. Insert a parenthesis. Didn't do it. There we go. Parenthesis x plus 1, close parenthesis, squared. That red should be the same as the blue. So if I go to graph, does a red, oop, I'm off. What did I do? Oh, it should be x minus 1 because it goes through plus 1. Good thing I checked. Graph now. There's the blue. And the red should fit right on top of it if I factored it right. And it did. So that's how it factors. Now the reason I have this problem in here is we have a linear factor that's repeated. So we can write a over the 2x plus 1, b over the x minus 1, but since it's times itself again, you just don't go c over x minus 1. Again, you do it over x minus 1 squared. It's still a linear factor, but the linear factor is squared. So we're going to turn these into separate integrals, but we got to figure out what these a, b, and c are. So the 3x squared minus 2 has to be, to get this common denominator, the common denominator is this. It has this, so I need to multiply by x minus 1 quantity squared. I'm going to do that in my head. I'm going to go x minus 1 times x minus 1, which is going to be x squared minus 2x plus 1. This is going to have to be times another x minus 1 and times a 2x plus 1. X minus 1 times a 2x plus 1. So that's going to be 2x squared plus x minus 2x, so that's minus x minus 1. And this one has this, so all it needs is the 2x plus 1. Okay, so this has to be a times this plus b times this plus c times that. All right, I've got x squareds over here, I've got x squareds there. So I'm going to look at my x squareds and think I have 3 of them. Has to be, I have ax squareds there, a number of x squareds. I'm going to have 2b worth of x squareds. And I'm going to have no x squareds there. I'm going to look at my x's, the next lower power. There's none here. So I have to have none here. So minus 2ax's plus minus bx's plus 2c. The right a, b, and c has to add up to be 0 there. And the constant is a minus 2. And that's got to be plus a and a minus b and a plus c. Okay? Now I need to solve these. You can do adding your substitution, whatever you want to do. I mean, you could solve for a by saying it's 3 minus 2b, putting that in for the a here, and then combining the b's. And then try to figure out, anyway, you can do that. I'm just going to do matrices. So I'm going to go second matrix, edit A, 3 by 3, and my numbers are 1, enter, 2, enter, and 0 for the C's. I have minus 2 for the A's, minus 1 for the B's, and 2 for the C's, and then I've got 1 for the A's, -1 for the B's, and 1 for the C's. Then I'm going to go second matrix, edit, B, and my constants are 3, enter, 0, enter, and -2. Oop, I messed up. Second matrix, edit, B. I want to do a 3 by 1. I forgot to get over into the matrix. Enter. 3. Enter. 0. Enter. -2. Enter. Second quit. My answer is going to be matrix A inverse. That's the x to the -1 button. Matrix B. And that's the answers in decimals. Math, enter, enter, change it to fraction. So A is -5/9. B is 16/9. And C is 1/3. So this A can be pulled out, and it's -5/9 of 1 over this dx. The B is 16/9 antiderivative of 1 over that dx. And the C is 1/3 integral of 1 over that dx. Okay? So we get -5/9. The antiderivative of this, do a u sub for the 2x plus 1 if you don't see how this becomes ln absolute value 2x plus 1 divided by a 2 because of the 2 there. If you take the derivative of this, you get 1 over this times the derivative of the inside times a 2. And so you have to have a 2 to cancel it. You get 1 over that, which we have, times the 2, which we have to get rid of, plus 16 over 9 ln x minus 1. It's a 1 in front of it, so there's no, you don't have to divide by anything, plus 1/3, don't automatically assume ln, integral of x minus 1 squared with 1 in the numerator dx. To do this one, I'm going to do u equals x minus 1, du equals dx. So this is like 1/3 integral of 1 over u du, u squared, which is u to the -2. So I add 1 to that, so I get u to the -1, and I have to divide by -1, so I get this becomes 1/3. Antiderivative of this is going to be -1 over u, which is x minus 1, plus c. So I have this plus that. This one I did in a separate video because it gets messy. Let's go to the back page. If you have a degree higher than the denominator, you need to divide that into that. So you got x to the 3rd minus 5x plus 1 divided by 2x squared minus x minus 1. And some of you don't remember how to divide. You have to say, what do you take times 2x squared to get x to the 3rd? It's got to have an x, and it's got to have a half. The half gets the 2 gone, the x makes it x to the 3rd. So we multiply 1/2 x times 2x squared, we get x to the 3rd. 1/2 x times x, negative x is -1/2 x. 1/2 x times -1 is -1/2 x. Oh, this is squared there. Forgot that. I'm supposed to subtract, so I draw the line and change the sign so I can add like terms. These cancel. I got only the 1/2 x squared. I have -5x's plus a half x, so that's -4.5 x's plus 1. What do I take times 2x squared to make this? I have to multiply it by 1/4. So 1/4 times 2 is 1/2 x squared. 1/4 times -1 is -1/2 x, and 1/4 x, multiplied by 1/4, and 1/4 times -1 is -1/4. And then I have to subtract, so I draw the line, change the sign so I can add like terms. These cancel. I get -4.5 plus 1/4 is -4.25x, and I have 1 plus 1/4 is 1.25, or 4 1/4 x minus 4 1/4 x plus 1 1/4. Anyway, that says that this fraction is this plus the remainder over the divisor. So it becomes the integral of this plus the integral of the remainder over the divisor, which I find it factors to 2x plus 1 and x minus 1 because we factored that earlier. So now I'm going to do my partial fractions to do this. I can integrate that pretty easily, and I hope you can too. So I'm going to have, that's a linear factor, there's none squared, so I'm just going to have a over 2x plus 1 plus integral of b over x minus 1, and both of these with dx's. I got to figure out the a and b so that if I add these two fractions, I get this in the numerator. To add fractions, I need common denominator, so this one would have to be times an x minus 1, and on numerator and denominator, and this one have to be multiplied by 2x plus 1 in the numerator and denominator. So I have x's. In this, I have -4.25 equals ax's plus 2bx's. And then at the constant, I have 1.25 has to be -a plus b. Well, since these are opposite and there's only a's and b's, I can add these two equations and I get -3 equals, those cancel, 3b, divide by 3, and I get b is -1. And if b is -1, I can add it over here and I get 2.25, divide by the minus, and I get a is equal to -2.25. So I have to do the integral of that, which is 1/4 x squared plus 1/4 x plus the integral of a negative 2.25 times the integral of 1 over 2x plus 1, and b minus 1 times the integral of 1 over x minus 1. So this becomes 1/4 x squared plus 1/4 minus 2.25. Antiderivative of that is ln absolute value 2x plus 1. Chain rule is going to put a 2 out there, so we're going to divide by 2. Minus ln x minus 1 plus c. Do u subs for the denominator there and there if you don't see how that works out to be ln's. This doesn't factor, so it is not a candidate for integration by partial fractions. Okay, so we got one problem left. This one's a little bit messy, not horrible, but it's not very nice either. Okay, there's an x squared in all these, so we pull it out. Actually, I'm going to pause and do this one separately because I need to go.